I would say the majority of change will be incremental, and that is, people have, when you say that, have a tendency to get disappointed. I would tell you that it's the incremental change that makes the biggest difference over time. Incremental change tends to be stickier.
Welcome to the Construction Disruption Podcast, where in just 30 minutes per week, we uncover the future of building and remodeling. Join us as we explore an industry that is constantly changing with new products, new practices, and new technologies. From builders to remodelers to executives, as well as those with outside perspectives, each episode of Construction Disruption meets with forward thinkers, as well as those simply in the know, in order to share their insights. Construction Disruption is created and sponsored by Isaiah Industries, a manufacturer of specialty residential metal roofing systems and other building materials. I'm Todd Miller of Isaiah Industries, and today our co-host is our sales manager, Seth Heckeman. Our producer here behind the scenes is Ryan Bell. Seth, before we get started today with our special guest, Bob Zabcik of Z-Tech Consulting, I'm curious, have you run into any contractors lately who are utilizing tech in new ways?
Yeah, a few. And it's exciting to see new implementation out there. You know, here at Isaiah Industries, the majority of our time is spent either working with contractors or oftentimes homeowners as well, but having close relationships with contractors across the country. And for a while now, we've seen them be pretty quick to adopt technology that improves their efficiency and makes their lives easier on the administrative end of their business. Where, think about a contractor who is, often doesn't have much support staff. For many years now, they've all been incredibly busy constantly, and often working out of their truck or at least on the road a considerable amount of time. So, adoption of technology where you can make that sell to them of additional services to take some of that administrative load off of them, whether it's, satellite imagery, that way they don't have to spend time measuring roofs anymore. They can go into an appointment with the measurements, or, CRM systems like AccuLinks that's they can program it once and it spits out materials lists and gives them their ordering sheets. And we're even seeing distributors like Beacon and ABC have portals that tie in directly with those types of programs. So they've been quick to hear pitches and sells and implement those into their business, spend more money to implement those into their business. But on the sales and marketing end, I think they have been a little bit slower, and there's some contractors we're seeing and working with who are adopting some exciting new technologies in their sales process, which I think is important for most of them to be considering, because they have been spending more money making these investments in these other solutions, but probably have not been doing a very good job of making sure that those additional expenses are accounted in their margin. So they need to improve and adopt new technologies. That way they can sell better, sell more, sell at a higher margin. That way they can sustain this life that is made easier by these other technologies. So more and more visualization software at the kitchen table, turning it into a design experience, a highly emotional experience for the homeowner, getting them very excited about how their home's going to look, pulling in the driveway, or how the bathroom's going to look, getting ready in the morning. That emotion is huge during the sales process. So programs like Hover, RentalWorks, new options out there to create those visualizations. Two, we're working with Engage right now, new platform for delivering presentations that is a total game changer on functionality, aesthetic, the experience for the homeowner at the kitchen table. So I am very excited about those. Honestly, we're not seeing many contractors be quick to adopt those. It takes time. They have to learn new things. Not many of them are the greatest about getting to the kitchen table in the first place and taking that time during their appointment. You can't use all that very well just standing at the truck tailgate or in the lawn looking at the house. So, we're going to have to be changing to engage homeowners, get them more willing to spend more money. That way we can get the margin we need, and also they can be all the more happy and excited about their new project.
I think that's interesting. We think a lot about using tech and utilizing tech for, the efficiencies of it, getting better at things, faster at things. But oftentimes we don't think about it. It all comes at a cost, too.
Right.
And I know that you are particularly passionate about that, helping contractors to know that when they are bidding things, they have to capture all of their costs. And, increasingly, some of those costs are tech. And so that's interesting.
Yeah, you don't want to be, at the end of the week, have less money than you anticipated.
Yeah,
that's not a fun spot to be in, and
Nope.
It doesn't have to be that way.
Yeah, absolutely. Good job. So our guest today on Construction Disruption is Bob Zabcik of Z-Tech Consulting. Some of you may also know Bob for his main gig these days as Technical Director for Metal Construction Association, which is also known as MCA, and it's the leading trade organization focused on metal in construction. Bob's been a good friend of mine for years. We've had the opportunity to work together a lot, off and on, for many years. Bob's a LEED accredited professional and a licensed professional engineer in Texas with 25 years of experience in the metal building products industry, or more than 25 years at this point. Bob worked previously for NCI Building Systems for over 24 years and then worked for Merlin Solar Technologies. Really, I've often said Bob is the smartest guy I know in the metal industry, so it's a real honor and pleasure to have him here as a guest today on Construction Disruption. Bob undoubtedly knows better than most people what some of the newest products, practices, and technologies are going to be in the construction industry going forward. Bob, thanks so much for joining us today and for your time today. Before we get started with maybe some meatier questions, tell me a little bit about what really fueled your passion for devoting your career to construction, and not just construction, but really you've spent most of your time on the more technical side of things. So I'd love to hear what kind of fueled that for you.
Thanks, Todd. No, first off, I wanted to thank you for having me, and really I sincerely appreciate the comment coming from such a well and duly respected person such as you. That's very meaningful and touching. But with all due respect, sir, it's not true. I've worked with some really smart people in the trade association world. You'd be amazed, and it's really an honor and a pleasure to be able to do it. I'm so happy right now making the transition from really industry into the consulting and trade association world, and I get to work with a lot of folks who very similar backgrounds, similar passions as myself, and we all try to work together. And I'm telling you, you tend to not know many of these people because they're very behind the scenes, but they are all highly intelligent. So, But anyway, thank you very much. I appreciate that. So me personally, it's kind of a funny story, actually. I knew at a very young age I wanted to be an architect. Really even, as like a 10-year-old, started sketching out floor plans and homes. I was very driven by, spatial relationships. And yeah, it was really fun. I took the industrial arts drafting courses in high school, and that's what I wanted to be. And then when it comes time to go to apply to college, I went to the University of Texas at Austin and applied to the School of Architecture. And ironically, I did not get in. At that time, and I think it's still true. It's a leading architecture school, and it was difficult to get into.
Absolutely.
Really above and beyond what the university requirements are. Yeah, and so my father, who knew the Department of Civil Engineering head, called him up and asked him his advice, and he said, "We have an architectural engineering program here at UT, and maybe you'd be interested in that." So I applied and got accepted into the engineering school there. And, I really realized later on how hard work being an architect is, and I probably am happier now. I mean, that's a dedicated group of people, I'm telling you. Oh, my goodness, they work hard hours, long hours, and they are truly devoted. But anyway, so I really enjoyed the engineering side of it. And in fact, my father was in the metal building business. He was at Metallic Building Company for many years, and really saw that company go from really a niche metal fabricator into a national metal building manufacturer. And as the old saying goes, the red oxide gets in your blood. So I did, after I left college, I went to work for a consultant here in town. I did what just about every other engineer does. They do design work until they get their PE, and then they kind of look at their careers. And so I wound up going to work for NCI Building Systems, was a parent company, a metallic, after I left the consulting business. And so what I really like about it, what I do, combines my two passions. I mean, I love math and science, I always have. And I also enjoy being creative in a getting your hands dirty kind of way. And that's what this enabled me to do. I started out doing design work, but then I got quickly into R&D. I had a test lab here in Houston, Texas, and you know, I was in charge of it, but I was not afraid to pick up a screw gun and help them build specimens for the test bed. They probably didn't want me there sometimes, but it definitely enabled me to kind of combine those passions.
Wow. So what are some of the specific areas that you've worked in over the years, or maybe particular research you've been involved with, or design development?
Well, as you know, with metal, it is a very versatile material, and it lends itself to a lot of different applications. And it is, contrary to what a lot of people might think about it, it's light relative to other construction materials because, it's a ductile material. You can make it and hammer it thin, and you get it, roll it out thin and put it in all these unique shapes. You can paint it before you put it in all these unique shapes, and with amazing paints that work extremely well. So it's just a lot of years of development and research behind it, and just being able to build those things and work on a test bed. And of course, when you're working with steel, because it's light, wind loads tend to take kind of a unique, have a unique effect on a metal roof and metal walls. So a lot of our research is driven by wind. We have been working pretty diligently, as you know, through Metal Construction Association, University of Florida, for a discontinuous metal roofing project. We've developed test methods that get into edge metal testing through some of our research and efforts with groups like Rickawi. We've discovered, some of these building failures initiate at the edge and at the corner, and so there's been some research and things driven there. And so we've really focused in at wind design, but then and it continues to be a big focus. But now there's other areas, when you use metal as diaphragms, maybe not so much in the residential world, but pretty common in commercial construction. Now I got to look at seismic performance, and those provisions in the building codes are changing drastically. We can talk about why. And it really all kind of just comes down to public safety. At the end of the day, as an engineer, my primary duty is to provide people a safe space to live, play, worship, relax, whatever they're doing, and they need to feel safe in that building. And so we focus very much on public safety in our areas of research. And there are business aspects to this too, better insurance rates, and enabling companies to fine-tune their products. And but really what drives this is public safety.
Wow, that's interesting. I like that. And I don't normally think in those terms, so that's pretty neat. I know that, like me, you've devoted a lot of time to trade associations. You volunteered a lot with Metal Construction Association and other groups for a lot of years, and now you serve as a consultant. I'm kind of curious from your perspective, what are some of the benefits of trade associations that you really see driving construction to higher levels, better levels, of course, supporting public safety as well?
Mm-hmm. Well, I think the biggest thing is that steel. What makes steel unique and how the trade associations interact with the rest of the industry, as you pointed out, is that there are a lot of different trade associations, and that is because steel is such a versatile material and is implemented in so many different ways. So the manufacturers, they all kind of have slightly different approaches to market. And then there's some regional aspects to it. Canadian codes and standards a little different from American codes and standards, etc. But really, that's driven by that versatility of steel and the resulting diversity in the marketplace it offers. But at the end of the day, as trade associations, and I've not counted them, Todd, but as well as I do. There might be as many as a dozen or 20 between the U.S. and Canada. But we really truly operate in a lot of ways, particularly when it comes to the technical stuff, as a single trade association, because we all share the same mission. Our mission is to promote the use of metal in construction, in the United States and Canada in any way we can, and that means a lot of different things. Public safety, as I said, is the leading cause of it, but we all benefit from that approach. And behind all that, then, there's some basic research that we have to do as an industry, because it's common to everybody. And so rather than have all these individual manufacturers do all this research and all kind of collectively find out the same thing, we work together as a group to pool our resources together and do that basic research, and we get an economy of scale from that. And then we take the results of that research then, and that's all well and good, and that has its own value, but what do you do with it? And so we take it to the next level, and this is where the effort really intensifies. You take this, then you do your analysis on it, and then you've got to go sell this to code officials and through an ICC hearing process or an ASCE standards development process or NFPA or any one of these construction standards that are out there, code or standards that are out there, and say, we've done this research, this is what we found out, we can make buildings better by doing this, and that's a very high level explanation. These wind up being long and involved, I'll use the word debates, that happen over periods of time. It takes a long time to get them implemented into codes, but ultimately that's our goal. Take that research, put it into the codes to promote the use of steel and other metals in North America, and we're all focused on that. So because of that focus, we actually, in a lot of ways, operate as a single trade association. And really the point on that is the American Iron and Steel Institute. They kind of truly provide that structure for us to work within.
I'm fascinated by that too. I have not really thought about it in that perspective of public safety, but in this whole process of code developing and being reviewed every few years, something that we're running into more and more, going back to the public safety and how wind is the biggest factor in a lot of areas, and an emphasis on code, or these constantly, it feels like, and dramatically increasing wind load requirements, especially in coastal areas. Who is driving those increasing code requirements? Are there either our industry or other industries coming in saying we can meet those code requirements, make everyone meet them, or is it legislators acting on behalf of their constituents, trying to push that public safety forward? How is that process playing out right now?
Well, it's kind of all the above, but I'll tell you that a big driver in a lot of this, you actually already kind of hit on it, is technology. Because the wind research that's in the codes now, that's commonly used for low rise and also steep slope building, what they call low rise construction, but that could be low slope or steep slope either for a roof. But that research, the fundamental research that provided those wind loads, was done at Western University in Ontario, UWO back then. They, in the 70s, and so even though wind really hasn't changed that much in the 70s, the ability to take pressure readings, literally every microsecond has evolved. And so what happened, particularly with this latest kind of raising of the bar of the edge zone winds in the coastal regions, was driven by technology. They went back and they reviewed that research, and they found that the research was all done correctly, but what they didn't have is ability to sample these wind pressure taps at the rate that they can sample them. So what they discovered when they went back and kind of reran some of these tests under newer technology, they were missing these spikes in the wind load. And so that were just there for a few seconds and then dropped. And it's the kind of stuff like in a heavier roof you wouldn't really see because there's a mass effect, right? So the spike in the wind load is counteracted with an acceleration of a mass that kind of subdues that spike. But in metal, as I mentioned, is a lighter construction, so that effect is lessened. And the insurance industry really looked at this and said, we're seeing some roof issues in certain areas of the country. We think this might be why. And they reran that research, and they found that, it's not that any of the research was flawed or the products was bad. It's just they had the capability to do that, to do that sampling. But really, it even goes further back than that. I mean, Hurricane Andrew in 1992, right, was really what drove a lot of this kind of stuff. And that was less on the research side and more on the product listing side. Right? So now we have Florida. We have, of course, Miami-Dade County has a listing system. Texas has one. That was largely a result of Alicia in 1986, a storm I'm very familiar with. I personally went through it. And it was when those two things combined, and your research is, or your, not your research, your testing is there in the open for anyone to pull down online and look at at any point in time. It just changes a lot of things about how these materials are designed and how they're implemented, and so that's what you see. It was so kind of all those factors working together under this opportunity that the new technologies gave to reinterpret the testing. That's how I'd sum that up.
Interesting. Well, that's helpful context because, me, not an engineer, just a sales guy looking at the numbers, this looks like apocalyptic levels of wind. But what I'm hearing you say is it's not sustained wind. It's those microsecond pressure spikes. Is that right? And then but depending on all those other factors coming into play.
That is correct.
Gotcha. Interesting.
There were two aspects. I touched on the temporal or the time-based side of it, but there's also some spatial micro zones that would come because as the wind hits, it separates into streams, and it's that stream separation. And these individual streams can go different routes around the building, but it's where they separate that you see this quick pressure variation over short periods of time and confined within certain areas. So if you summed up the total wind load on the building, what you would find it's pretty much the same. It's just they're taking wind load that was previously part of the center part of the building were away from the stream separation and kind of moving it, so to speak, out towards the edges. And so you see a big jump in the edge wind zones, particularly in the corners and the ridges, but then in the middle of the field of the roof, it's actually kind of dropped a little bit.
Wow, interesting. So in addition to wind uplift research, what other areas of research and things is MCA currently involved with?
Well, we're always focused on hail, which is an important thing for a metal roof. So there are a lot of insurance companies that recognize metal has great performance in hail. I don't think anybody really argues that it doesn't. It's just a question of there's some difficulty in the industry in establishing between what's an aesthetic claim and what's a functional claim, and this winds up being a large area of discussion that quite often, unfortunately, might happen in front of a jury. And so really what we're trying to do there is less about the performance of the roof in hail, because that's well known, but working with the insurance companies to help them understand that these little micro divots doesn't damage the coating, doesn't damage the paint, doesn't withhold water. It is zero effect on the performance of the roof over time. And in fact, you got to get up on top of the roof with a magnifying glass to even see it. Is it really a hail damage? And so that's actually an important area of research that we're going through right now, working with MBMA, Metal Building Manufacturers Association, on that project. And then other projects that I mentioned, or actually most of them relate to relate to wind. You have a discontinuous metal roofing, which is kind of wrapping up. That's where we're looking at how the ability of certain roofing systems, like metal shingles, they have the ability to kind of breathe, so to speak. So what does that do to the wind load, both temporally and spatially, right? Does it change? Does it actually produce? And we know through what the asphalt shingle industry has already discovered, it does tend to reduce and spread out these wind loads. So how do we get that into the hands of the designer to help him make a more efficient design? Edge metal testing I mentioned, so we work very closely with a group called Rakawi, that is a roofing industry consortium focused on hail and wind damage and how to mitigate those things and do better design practices. It's a research-driven organization, and we work very closely with them and have developed an edge metal test particularly with low slope roofing, you get a spike of the wind loads because the stream separation is actually along the edges and the corners of the building. And a lot of these failures actually start as trim failures. So we don't see really ever massive roof problems with wind in metal roofing. What we see are little pieces here that peel up. Now there's water damage that can follow, and so you know there's important to address those things. But the damage itself is actually pretty well contained, which is good news because that means your mitigation strategy is pretty well implemented, which is better fasteners and really all those better fasteners, tighter trim systems. You know, the manufacturers all know this. And the designers all know this. Really, the biggest issue that we're seeing, and this isn't just metal, I think this is across the entire industry, is that those proper installation techniques don't get transmitted to the field very efficiently at times. And then when they are transmitted to the field, or maybe when they're not transmitted to the field exactly right, is there a follow-up quality procedure, a code an inspection, a warranty inspection, or a local building official inspection? Maybe go catch them from a QC standpoint. That's where we're seeing really the biggest areas of concern. So we're working very, very closely with insurance companies and code officials to kind of tighten up those things. But I think really one of the more exciting things, and it's just, I mean, one of these hot off the presses, Todd probably, this might even be news to him, we're getting ready to start a research project with Oak Ridge National Laboratories about thermal bridging. We all know thermal bridging isn't a good thing. It compromises the ability of roofs and walls to be insulated, but it could be something that you can short circuit or intercept, so to speak, and drive to another energy source and actually capture energy preferentially through the thermal bridging.
Oh, wow.
So we just recently, so Oak Ridge National Labs contacted us about this a few months ago, and we started talking. We like, this is right up our alley, and so we Oak Ridge submitted. We signed on as a sponsor or a participant in the program, and then Oak Ridge National Labs submitted on the DOE, and it was accepted. So this project will start in the next couple of months. So it's very, very exciting. And then lastly, I think to really drive a lot of this stuff, and this is where the rubber meets the road, we do a lot of work on technical bulletins and white papers. And so we got to do something with this research. It's great to have it, but we got to turn it into a benefit for somebody. And so we do this through our technical bulletins, Metal Construction Association, and their white papers, and they're freely available to everybody, and not just members, but anybody in the public can go and download and read all about it. So those things are really important to us, and again, helps us advance the industry.
I know it seems like probably once a week I'm sending an MCA white paper to somebody.
Absolutely. Incredibly valuable. And I want to highlight, thank you for leading the way in a high integrity way on the aesthetic versus cosmetic or aesthetic versus functional claim process on the hail side of things. That's something we're dealing with frequently, whether from adjusters or homeowners, and lots of confusion. And I think getting something published out there, again, high integrity, truthful, upright and forthright way will be very helpful for all involved and put our industry in a better position.
Yeah, I remember a few years ago I was called in by an insurance company as an expert witness on a hail claim. And, I'm 20 foot in the air hanging onto this metal roof down there with, like you said, exactly a magnifying glass, looking at these things that possibly were hail damage, but didn't compare nearly to the damage from the foot traffic that my 220 pounds was probably creating on my own. And I'm just like, you got to be kidding me. This is ridiculous. So one of the things I wanted to ask you about, we hear a lot about the red list of chemicals that's out there as far as chemicals that down the road are going to be more heavily regulated. Do you see that having an impact on construction down the road, or are there other things that you see having an impact that we're maybe not thinking so much about today?
Oh, red lists are certainly a big part of that. And that one's really kind of tough to address because not everybody's a chemist. And when you start looking at red list chemicals, and particularly as a manufacturer, and you get this list, and how do you know if those things are in your product? And especially when you consider some of the newer ones, it's not just intentionally added. They actually, it has to be there. So basically, in any concentration. Well, I mean, anybody can tell you that when it comes to chemical concentration, zero is zero and probably never achieved. I mean, entropy just doesn't work that way, right? There's a little bit of everything and everything. And so we have to really work as an industry, do our market outreach, and work with those who are in the know to help them understand that there is an aspect of this that's not largely addressed, and that's the exposure risk assessment. Some of the more advanced programs that take care of that, but I like to use the example of cadmium in metal. It's a trace element in steel and many metals, because those of you who don't know or remember from high school chemistry, the metallic bond, right? The magic of the metallic bond. Metallic bonds are wonderful things because they give strength to steel and other metals, as well as ductility. And metallic bonds are friendly to all metals. And so because of that, there's trace elements of different types of metals and other metals. That's just common and happens in nature. Nobody's adding that chemical, it's just there. But it'll never come out. Cadmium will never come out of steel because it's locked in there with the metallic bond. So what's the exposure risk, right? Zero, pretty much. So those programs really need to address that, and some of them are starting to, but by and large they take what's called a precautionary principle, which means that if it's in there at any concentration, it's bad and we need to deselect that material. And that's just not right, because look, I'm all for occupant safety and comfort. I already talked about public safety. I'm committed to that. But you got to look at the trade-off. If I'm taking a chemical out of something, fire retardants are probably a great example. If I'm taking a fire retardant out of a building product because that one is deemed as unsafe, and I'm replacing it with a less effective alternative, how is that safe? How does that help the building occupant? If it's not, now the building's more subject to fire. So you got to make those choices. You can't make them. They call those single attribute choices. You can't make single attribute choices. You have to look at the system effect, and you have to consider the exposure. That's a difficult thing to do. I get that. Those are long conversations with a lot of modeling and research behind it, but it has to happen in order to correctly assess those things. So that's kind of where I think we're headed on Red List. That's the direction. But really, to me, I think the biggest impetus of change right now that we're seeing is just the lack of skilled labor in this country. It's so hard to find contractors with availability and a skill set. I mean, metal has its own unique things that people skills and things. We're actually working with MCA is working with the National Roofing Contractors Association to develop some training materials, but it is really hard to find people, and we can manufacture product till our heart's content, right? For the rest of our lives, if nobody can install it, there's nobody available to install it, what good does it do? So we're really seeing a shift to factory built, where I have some predictable quality. I can put in those QC procedures, and there's benefits to us as manufacturers too. It allows us to utilize things like cash flow improvement techniques, like just-in-time manufacturing, which is becoming more and more. Go try to implement JIT on a construction site and let me know how it goes. Train wreck, right? Total train wreck. It's gonna, but you can do it in a factory setting. Okay, so now we can become a little bit more efficient. But at the end of the day, if there's nobody there to install it, it's not going to do anybody any good. And I really think that, to me, is the biggest thing we've got to address as an industry, and we're working on it in a lot of different ways. But it's got to really be a major shift here.
Interesting. So, switching gears here a little bit, I know that you and MCA have been pretty heavily involved with code and practice changes that have been driven by the Grenfell Tower fire in the UK a few years ago. Can you tell our listeners briefly a little bit about what happened in that fire and what, if any, long-term changes you see coming from it?
Todd, I'm glad you brought it up. I mentioned a couple of events earlier that changed construction and design for probably forever. Hurricane Andrew and the Northridge earthquake, and Loma Prieta also, the one that happened during the World Series in '89, right? But so that Grenfell Tower is one of those events. And it actually, your timing is important because it happened 4 years ago last month, and there's still a lot of conversations going on it. But it was, first and foremost to recognize 71 people lost their lives, an awful thing that should never happen. It was a unique fire because of how it spread. Because what happened was this building was been there since the 70s, I want to say, and it was a precast facade building. But as you know, there's been a lot of focus on energy efficiency in buildings in the last few years, rightfully so. There's also been a lot of focus on moisture management. I live in Houston, Texas. We've had the whole, many parts of the state, not all of them, but many parts of the state, we battle moisture problems and mold, and so ventilation's an important thing to keep the insides of buildings dry. And so there's been this kind of shift towards cavity wall construction, which isn't a bad thing. Cavity wall construction is nothing new. It's been used for thousands of years in low-rise buildings, but we're starting to implement it more on high-rise. And so this building had a cavity wall construction energy retrofit that was intended to increase energy efficiency and mitigate some moisture issues. So by having that cavity wall in there, it gave the fire an opportunity to spread outside of the building, as opposed to what usually happens is between floors. And so any firefighter who will tell you, things burn, you can't really stop them. They get hot enough, they're going to burn. What a firefighter depends on is certain behaviors in buildings that they understand and the fire and how it spreads and how it can be mitigated, and they depend on those behaviors in order to implement their firefighting and life-saving techniques. So when you get an instance like that where this is different and this happened and it's not something we'd seen before, it makes firefighting extremely difficult. And so like I said, it was a tragedy, but like any tragedy, there are things to learn from it. And I think one of the things that was probably the most important thing that we learned was that not that cavity wall construction is bad, not that using combustible materials in walls are bad, but that there needs to be a follow-up process. The testing obviously has to be there from the beginning. And there were some issues in Britain that have since been corrected, addressing kind of some lack of testing. Fortunately, we haven't seen those in America or Canada, and I don't think we will because our testing is quite different. But then there's also these follow-ups. Okay, well, did what get tested? Is that what got installed and how it got installed, and closing that loop. And I think that's going to be the single biggest thing, kind of like Andrew and the whole listing thing in Florida. There's this transparency. Here's my testing, here's my results. Now anybody can go download that data and look at my details, my installation details, go walk over to the job site and see that that's what got built. And closing that loop, and I think that's the important thing that'll come out of that. What I don't want to see happen is cavity wall construction and combustibles in the walls start getting a black eye because of that. Because really, what it came down to, there were technologies and techniques that exist right now today that would have prevented all of that. They just weren't implemented in that particular building, and so we're seeing those types of follow-ups. And like I said, we tend to have them in America in a lot of places. Other places not so much. But one thing we do have is a commitment to fire testing. And FPA 285 has been in our codes for a long time. That test is really designed to recreate a similar situation to what you saw in Grenfell and prevent floor-to-floor spread through a cavity or through a wall assembly, really. Not necessarily cavity. It could be any kind of wall assembly with combustible in it. And it's not new. Manufacturers have been doing it for years, and our commitment to that testing is probably gone a long way to the reason why we don't see that in the USA, and hopefully won't.
Wow. Very good. Thank you.
That's going to be interesting talking about the skilled labor shortage. Now, if one thing coming out of this fire is additional inspections throughout the construction process to make sure that what is being installed was actually what was designed and approved, making our way through that and all those parties working together through the install and not getting things delayed. We may have some to be better organized, may have some hiccups along the way.
Yeah, that's a good point. Interesting. So my next question sounds like something that would be on the dating game for engineers and other nerds. But if you were to say, wow, I wish that someone would come up with X being a construction product, practice, or technology, what would X be and why?
Oh man, right? We all want our flying cars, right?
There we go.
So give me a flying forklift. No, yeah, that's a question I thought of a lot. I'm going to give you this kind of weird off the wall answer, but I really think this is a game changer when it happens. And we're all talking about self-driving trucks. That's going to be a game changer, no doubt. Getting material to the site with a self-driving truck when that happens will be awesome. But other people have thought of that. We're working on it. We're testing it. I would love to see a self-unloading truck. I can't tell you how many times I've had a project delayed because material was delivered to the site and a forklift wasn't there, or it was the wrong kind of forklift, or it was too muddy to get the forklift out and get over there.
Yeah.
Over and over and over again. Give me a self-unloading truck. That has to happen. And that sounds far-fetched. We have self-unloading trucks in factories. I've been to factories where they do this, like where they're manufacturing some product in one plant and they got to transfer it over to another truck with other product on it that's going to a job site. They have that capability to do it in an automated fashion within a factory. And I look at those systems, I've seen them, I could see where something like that could be implemented in the field. And yeah, it'd be expensive and somebody'd have to pay a lot extra for delivery, but at the end of the day, not having the right equipment on the job site when the material arrives costs somebody a lot of money. And that is kind of a weird answer, but I really think that one's a game changer because I don't know, my career, probably at least 200, 300 projects that I know of had serious delays, that got compounded by the fact that they had the wrong equipment on the site when the material arrived. Couldn't get there, or the people that needed to unload it couldn't get there. It's just a big problem.
And now to boot, the carriers charge you huge fees when that happens also. I love that. That's a great answer.
Well, I work tell me about it. I worked for a publicly owned company for many years, and you can't close that contract until the material is unloaded off your truck. And the accountants are pretty sensitive to that, and the lawyers too. So no, it's that one. Don't sleep on that one. I think that's going to change a lot of stuff when that happens because it exists today. I don't know why nobody's thought of that yet.
So something like that I would see as really a major change, a positive change. As you kind of look into your crystal ball, do you think changes over the next 25 years, we're going to see these big quantum leap changes, or do you think it's going to be more incremental changes that we're going to see, which probably is what the construction industry, let's face it, has been known more for, has been incremental change rather than huge, big changes all at once?
I would say that the majority of change will be incremental, and that is, people have, when you say that, have a tendency to get disappointed. I would tell you that it's the incremental change that makes the biggest difference over time. The disruptors are not, they're just not that common. They don't happen all that often. When they do, somebody might make a lot of money for a short period of time, but eventually it's not a disruptor anymore, right? Disruptors always have a life, and at some point they're not a disruptor anymore. Incremental change tends to be stickier, tends to last longer, and I think when you have those things that happen over time, and people get used to seeing it, it becomes more permanent. Now, I will tell you, we're going to see what's driving those changes are going to change quite a bit, and you've hit on a couple of them already, but the first one that comes to my mind is, there's a lot of places in America where there's a tremendous problem with affordable housing. These urban areas become very popularized and very dense, and it's hard to get materials in and out. And then, let's face it, wealthy people move in and jack up the housing prices, and the teachers and the firefighters and the policemen can't afford to live there anymore. Okay, that's a problem. So this affordable housing crisis is very real in a lot of places in America, and we're even starting to see it in certain places in Texas. And I think that's going to drive change a lot. I've talked about factory assembly, really prefab, if you will, has some connotations on it that aren't great, but really that's kind of what it does. And they call them ADUs a lot out west, auxiliary dwelling units, but mobile home, fancy mobile homes, whatever you want to call them. I really think those are going to be a significant part of that. The other thing is really going to make change, drive change, and people might argue with me on this one, but I think it's pretty real, and that's climate change. We're seeing more and more flooding events, more and more wind events, hail events, fire, obviously what they're dealing with in California. Climate change is changing not just the way we design buildings, it's going to change how we build them, and it's going to change where and when we build them. And I think that's going to drive a lot of change in this industry, incremental and disruptive. Those things are going to, we're already seeing it. I mean, we really are. So all the research indicates it's just going to get nothing but more and more intense as time goes on. And despite, like I said, a lot of people, there's a lot of argument here and debate on it, but I know this. I know that if you can't get to a job site because of flooding, or there's damage because of wind or rain or hail, there's a problem, right? How many times have we seen delays in construction due to weather? And it's not just the rain, it's the wet ground, so those things, sure, they're going to impact us. They're going to impact us. I don't think there's any way we can avoid it. And within that, fire safety, we've already talked quite a bit about it. Fire safety is going to be the single biggest contributor to that.
Yeah, very interesting. Yeah, there's certainly no doubt about it. I mean, we're seeing more and more extreme weather, and you're right. I never thought about that, how much it does impact the ability to get jobs done, and that's a factor. So, thank you. We've covered a lot of ground today, and I really appreciate your insights. Been great. Is there anything that we haven't covered yet that you'd like to share with our listeners?
I mentioned a couple of events. There's always the events, right? We've talked about that. We'll call it the disruptive events, the Andrews, the Northridge earthquake. I think we just had one. Grenfell Tower. I think we just had one in Florida. That yes. Surfside condo collapse is going to change. And rightfully so. I talked about it already. About there's a follow-up aspect to construction that doesn't get implemented very well in certain places, and actually Florida's done a pretty good job with that. But what happened, and this is way early in the game, I understand that. I could be totally wrong a year from now, but what it appears like happened is that there was some long-term water management issues, some long-term maintenance issues, some long-term erosion issues that kind of were working behind the scenes that maybe people saw, maybe people didn't saw. That's the part that we probably don't know very much about at all right now. But the bottom line to it is that there was a thought process that once I've built a building and it's closed in and the occupants are safe and everything's fine on day one, day zero, if you will. Was that the case in year 45? What changes in that period of time? What do I have to do to go back? And in fact, they had a recertification process. We know that they were working on it. And it did. They did have some findings that maybe alluded to some of these problems. For whatever reasons, they didn't act on them right away. Probably financial. I mean, nobody's just got
Sure.
millions of dollars in their pockets to drop on a building repair out of the blue. But at the end of the day, it's going to really change how we do things in those longer terms. And I actually had I did a LinkedIn, short little LinkedIn blog about this. And I don't know if you saw it or not, Todd, but to me, this is all about the psychology of the second opinion. I'm not calling question anybody's ethics because I'm saying, I'm going to assume, and I think rightfully so, there weren't any real significant compromises in ethics. What happened there is you had somebody who walked in, what looks like happened. You had somebody who walked in, did an inspection, found some problems, and said, here's your problem. These are serious issues. I mean, we know that happened, right? These are serious issues. This is going to take you millions of dollars to fix. That's not something any building owner wants to hear. So they go get a second opinion. And I would too, right? I mean, just like if a doctor tells me I've got a serious medical issue, I'm going to go get a second opinion. And that's right. That's good practice. You should do that. There's a psychology of the second opinion, particularly in the consulting business, because your client walks in and he says, here's this report that this other person wrote for me, and it says some very disturbing things. Could you look at it? Well, that's not a second opinion, in my opinion, in my purview. That's a peer review. A second opinion means, hey, come out and look at this building, and that's it. You go out there blind and you see if the second person can find all those problems that the first person found, and if they do, then now that's a second opinion, and they're consistent. I think what they did was a peer review. And like I said, I'm not calling in question anybody's ethics. I mean, that's not the issue. It's just there's a psychology about a peer review that is not there in a second opinion, and vice versa. Those are different things. And, it's really easy to lean towards the side of telling your client what they desperately want to hear, that this really isn't as bad as this first person made it out to be. And that, like I said, not an ethical question. It's just like, because there were probably some signs that it wasn't as bad. and it's really easy to look at those and say, here, see, these are okay. So that's what I think is really going to change. It's subtle, but very important difference between a peer review and a second opinion. But second, really, the core thing is, what's going to happen? Are we going to go back and inspect buildings 40 years after the fact? That's going to make a lot of people uncomfortable. But that is going to change the construction industry forever, just like Grenfell, just like Andrew, just like Northridge, just like Loma Prieta. And it's just a reality. And this is why, we evolve as a society, and why I'm committed to doing the things that I can in terms of research and help everybody through these transitional processes, because I can't save the world, and I'm not going to be successful if I try, probably, but I can help people save the world, so to speak. And that's what I think we're all trying to do. Just work together as a team, come up with better practices, better ideas, test those ideas in safe environments, and implement those changes and those new technologies in new and better ways to save lives. And that's really what it's all about for us.
Wow, good stuff. And I had no idea that this episode would kind of go down this path of, looking at how oftentimes these disasters and tragedies can be the motivators of change and development. Didn't realize we would end up there, but especially since you started talking about public safety, that was the natural place where, we would end up. And so very, very insightful. Thank you. Pretty neat. So I'm curious, if why might someone want to connect with you, and if they wanted to connect with you, how would they go about doing that?
Well, I would say that first off, if you're looking to get in contact with me in the context of metal construction, to route it to the Metal Construction Association, easy email to remember: info@metalconstruction.org. That goes directly to the MCA staff, and then they will route the questions appropriately to me, my Code and Standards cohort, Andy Williams, or and if Andy and I are pretty well connected in the industry, obviously if we need to bring other people to help us answer questions, we're more than happy to do it. Away from that, my personal, my professional email, personal professional email, if you will, is Bob, B-O-B, at ZTECH-consulting.com. Probably the best way to get a hold of me, or LinkedIn, either one. And I'd love to, I love philosophical discussions, and I'm happy to have them with just about anybody at any time. So more than welcome.
Good stuff. Well, thank you. Well, thank you again for spending time with us today, Bob. This has been great, and I know our listeners are going to find it very insightful as, again, our whole purpose here on Construction Disruption is to look at those things, whether they're big, and your distinction there between disruptors and yet incremental change was great. Whether they're big or smaller, and whether they're driven by something or just happens in someone's great moment of enlightenment. This was a great discussion, so thank you.
Well, Todd, thank you for connecting with Bob, your relationship with him that brought him into this episode of Construction Disruption. I learned a lot. It's inspiring for me hearing someone with that mind, passion, intellect in our industry, and giving me more context of the bigger picture rather than whatever I am working in, head down in on a daily basis, and thinking on behalf of our customers too, down at the homeowner level, the contractor level. So much of this impacting them that they don't often see. So understanding the big picture of how all these parties are contributing, how all these parties are influencing what we're dealing with on a daily basis, and giving us real value, context, and then resources like the Metal Construction Association that we can keep in touch with and understand ongoing what is happening out there.
Yeah. I think sometimes people don't understand exactly how much goes into building materials. You think, well, it's a formed piece of plastic, it's a crunched piece of metal, it's whatever. But yet a lot of engineering and research and thought has gone into that. And, the way Bob was able to bring that back to this emphasis on public safety, I think was really critical because as we've seen in some of these disasters that he mentioned, whether it was a natural disaster or a man-made building failure, the loss of life and the potential damage and tragic nature of that is really quite great. So it's really important how we do build our buildings, no doubt about it.
Yeah, it's of great consequence, no question. And now I'm going to be more mindful of when I see a news story. I was watching the Surfside daily. I think as many of us were hoping, praying for better outcomes, but I had not taken the leap then to think much about, okay, how is this going to affect our business on down the road? And I think that foresight is going to be helpful in me and my thought process. That context is only getting bigger, hearing what his perspective on the red list applications as well, where the sphere is getting forced open to include probably more legislators, more environmentalists, more individuals at the table. He shared some of his frustrations and seeing, it just turning into a polarized black and white conversation, how we converse about so many other things, unfortunately. How can all of us from our own perspectives really contribute to a gray, let's have a true conversation about this, considering all elements, and rather than bickering with each other and not really accomplishing much in the process.
Yeah. Yeah, I think if I took, or a big thing I took away from everything Bob said was being very thoughtful, and anyone out there in the construction industry, thinking big picture, thinking public safety, thinking about how do I be fair, how do I be unbiased, even where he talked about, peer review versus a second opinion. And I know I've been called in a lot of times to give second opinions on roof failures or roof situations. And certainly if I know what the first opinion was, I approach it a little differently. I'd much rather be brought in, not told anything about it, say, Todd, give me your opinion, then they can take that information and compare the two. But, I think that's a responsibility really that all of us in construction, no matter where you are in the whole construction industry, need to really have that commitment to high integrity and doing things the right way, because public safety is at stake here.
Operating in the interest of the end consumer, the person, the public living in that, and living, worshiping, working in that building, rather than our own egos and agendas a lot of times.
Good stuff. Well, thank you for helping out today. I appreciate it.
Absolutely.
Thank you also to our listeners for tuning into this episode of Construction Disruption. Please watch for future episodes of our podcast. We have more great guests on tap. One we do have coming up in the future will be a forensic engineer, and we want to talk more with him about the Surfside disaster as well. But until next episode, we encourage everybody, change the world for someone, encourage them, make them smile, bring them some hope. Those are all, despite what all we talk about here, those are some of the most powerful things we can do to change and impact the world one interaction at a time. So God bless. Take care, everyone. This is Isaiah Industries signing off until the next episode of Construction Disruption.